In this video, we're going to go over the rest of section 1.7, which is kind of a variety of word problems, which can be the challenge. Not that all of them are hard to solve, but it's just that there's more variety than what you saw yesterday in the first part of the video, where it's a little more straightforward. You substitute here. This is kind of how things are written. This just has some variety. So what I want to do is go over some, and we're actually going to adjust what your guided notes look like. Due to being in the distance model and everything that we have going on here. So there'll be a couple new ones, but we'll talk through them when we get there. So this, as you can see, is in your notes. So let's kind of break down what's happening. It says a square of side X is going to be cut out of each corner of an 8 by 15 piece of paper. So you kind of have that picture there. I'm going to start from scratch. So here is my 8 by 15 sheet of paper, and it says we're going to cut squares out of each corner. So, and their squares are X by X. So X, X, they should be the same to the best of my ability. This is what we got. So X by X. Okay. It says then we're going to use that, we're going to fold up the sides to form an open top box. So basically in this picture that's here, this would be gone, this is going to be gone, gone, and gone. These dotted lines are where it's folded, and so this piece here would then go vertical and stick up like at you out of my screen here, here, and here. Okay, so on this paper here, I'm going to use my little eraser. So this is gone. Is that what was cut or ripped out? And if you know how to grab a piece of paper and try this, go ahead. And then like it showed over there, I would fold it right here, and then this would be my, in this case, left side. I would have kind of my front and my back would fold up, and then this would be that right side over here that would fold up. So there's no top. This part right here is still the bottom, and then those are the four sides that fold up. Okay, so going back to this problem, what it's asking me to do is write the volume of the box, and then here's this phrase from yesterday, as a function of x, which means in my volume equation I can only have x, which again, x is this cut that you made to get something to fold up. Okay, so some steps you can take here, just like the last ones. Like first, what is the volume of a box? Like how do you find the volume? So I would say volume is base times, let's do length in there instead. I'm going to change it all together. I worry sometimes base gets messed up. So let's use length with height. It'll be a little bit easier. Okay, I'm going to go back to this picture so it's a little bigger. So my length would be like this part here. That could be my length. My width would be that part. Now my height, it's kind of weird, but this is where this piece is going to fold up and then stick out at you. And so this would be kind of that height, because that's now that part that comes up. Okay, so I need to get all of these in terms of x. So let's start with my length. My piece of paper started going that whole thing with 15. Now my width is only here to here. So if it was 15, think what was taken off, so I can do this in terms of L, and in terms of X I should say, to get what L equals. Well, L, like I said, it was 15. Over here you cut X, over here you also cut X, so you cut off 2 corners or 2 X's. Okay, let's look at your width. Your width from here to here was 15. You lopped off X there. You lopped off X there. So your new width, I'm sorry, is 8. Sorry, I apologize. It's 8. And so now your width is, everything all messed up here. All right, back to what I'm doing. 2x. Like I said it right. You lopped off X. You lopped off X. So your width was 8 minus those 2 x's on each side. And like I said, if it helps you, grab a piece of paper or grab a paper towel, whatever you got. Cut the corners off or rip the corners off out of each 4 corner. and then fold those little flaps up and you can get a visual of what's happening. Okay, so if I go back to here and I kind of make this substitution, my volume equation is now 15 minus 2x, 8 minus 2x for that width, and my height is x, because those were the pieces that folded up right here. Okay. All right, find the domain V as a function of x. All right, so domain, those are the inputs. Your input is x. Now in this context, like I can't cut negative infinity. You can't cut negative numbers. So in general, you have to cut something so that you can actually fold it. So this thing's domain is going to start at 0, but I'm not going to include it. So I'm going to use a parenthesis because I have to cut something. Otherwise, it's still a flat piece of paper. Okay, now how much or what's the max? Now that's a little, you got to kind of think a little bit here because it's how much can I cut? And remember, you're cutting from both sides. Okay. Now, for example, I can't cut infinity off because that doesn't make any sense. I can't cut negatives. We already established that with the 0. But what's the most you could cut off? Okay, let's just start at random. Let's say 10. So if I went to this thing, and I'm going to actually draw a new one. Just a little bit smaller, 8 by 15. So if I took my scissors and I cut 10 from here, I actually can't cut 10 there because there's only 5 left. So I know I can't cut 10 because I would cut 20, which would leave that whole 15 gone. Okay. So if I think about cutting half of each side, well, the smaller of the halves is going to be with that 8, which would be 4. So if I take that same picture, I'll use 8 and 15. If I cut 4 and 4, that's okay with the 15. If I cut 4 and 4 off the 8, though, I cut the whole side off. And so then there's nothing to fold. But we're going to actually use that 4 because you could rip just a little less than 4 and have something really, really small to fold up. And so my domain is actually going to stop at 4, but I have to use that parenthesis again because I can't use that number. Okay. So to kind of generalize this, you're always going to start at 0. And that number came from half the smallest side. So if your smallest side was 30, you would have a 15 there. Okay, because what's going to change in these problems is just what these starting numbers are. So your equation is going to look the same, except for it's going to be different numbers with the 15 and the 8. You know, it's going to be 0. What goes here is always half the smallest number. Okay. All right. C then, graph V as a function of x over the domain, and use the max finder to find such a volume. Okay, so suggestions. When you are typing this into your calculator, do not distribute. You do not, especially if you're solving graphically, don't do extra algebra because you just might get it wrong and then you get the whole problem wrong. So graph it in, we'll put Y1 here, exactly like it is. Don't do anything to it. Okay, so when you get that entered, this is what your picture will look like. I know I'm not going to really need to change the window very much because my domain is 0 to 4. It should be a little bit drawn better. So here's 0, here's the 4. I can't use anything after that. So even though my function keeps going, it's not relevant. And I want to find this maximum at the top here. So remember, that's in your second trace. Go down to maximum. You know, say look between 0 and 4. Make life even easier. And your answer you get is this point. So always use 2 decimals, that's a comma, 90.74. So you didn't need to change your y max. Sorry, I talked about the x, but your y you do need to make bigger until you can see that top. So about 100, you should be good there. Now be careful, the point's not your answer. It wants to know, use the maximum finder to determine the maximum volume. Well, the maximum volume is your y, because v is the dependent variable. And so your answer, not working, there we go, should be 90.74. Okay. All right, now the how big to produce that, how big should the cut be? Well, that cut again is x, and x is the 1.67 number that comes on there. Okay. All right, so that's just kind of a preview. One of them is going to be in your homework, so try it in there, reference back to here as you do that to kind of help you through. All right, here is the change. So in your notes, you have next have a problem about like a grain pile or something. We're going to kind of change our focus here and not worry about that grain problem yet, or really this quarter at all, but focus more on kind of the ones that are more common on your assignment and go over some different concepts that we want to highlight in Pre-Calc A. So if you need to, pause this video as we go. If you need to write the problem down, you can grab a new piece of paper and just staple it to the back of your guided notes to finish off. This is the last guided notes we have. So I do apologize for a change here, but we want to, with the current situation and me being quarantined, trying to get you the most useful information that we can. So, all right, let's hop in. So Beth is looking at 2 job offers she received. The first is a salary of $25,000 with a 5% on her sales, and the other is $20,000, but then plus 7% of her sales. So what would Beth have to sell to make the second job more attractive than the first? Okay, so first we need to figure out how much money is she making off of both when we don't know her sales. This is kind of the unknown, and you know that's the unknown because that's what it's asking you. How much do you have to sell? So let's pick a variable for sales. We'll just say X is the money on or from, either way, sales. Okay, so let's look at job offer number 1. So she's gonna make $25,000 no matter what, but then she gets 5% of her sales. Remember, with percentages, we have to change them to that decimal. So it should be 0.05, and then the sales is what we don't know, so we put that X variable there. Okay, her second job offer is that base salary, whoops, $20,000. And now she's getting 7%, so 0.07 with that X for her sales. Now we want to know when they start to be more attractive. So basically, I want to find when the 20,000 one starts to be bigger than the 25. So I can go graph. That is a very that works. Your window is going to be very, very big though, because you're in the thousands. You're already in the 25 and 20,000s. So you're going to need to get very big. This also, we could find just when you start being equal, and then after that was when the second will be larger. And this is actually easier to solve algebraically because this is just linear. Like you've got, here's your slope, the 5% and 7% are your slopes. Your starting, your B value are those thousands. So if I subtract 20,000 over, I have 5,000 left. If I subtract the 0.05, I have 0.02x, divide, and I get x is 250,000. So you, depending on what you're selling, have a lot to sell in order to make up that $5,000 difference in your base salary. So you would need to sell $250,000 worth of whatever she's selling in order to make that second job offer more attractive. All right, here's my second one. It has to do with solutions. So it says Ryan is mixing 2 solutions. One is a 25% concentrate and one is a 23% concentrate. And he or she wants to make 25 milliliters, that is 18% concentrate. So how much of those 2 should be used to achieve that? Okay, so first we gotta talk about concentration. Concentration works very, very much like percent. So if you have a 15% concentration, that means 15% of the solution is, whatever, if it's acid, if it's sugar and Kool-Aid, whatever, that's your concentration. So it's really a percentage. Same thing with that. And so it's kind of, and I'll generalize at the end here, but concentration is amount times, and I'll say percent decimal again, decimal, kind of what I used up here with that, like 7%, that same idea. Okay, so we don't know how much to use of each. That's what we're looking for. And so let's say we use X of the 15%. Okay, now what often is done is someone also then goes and says, okay, well, I'll use Y of the 23%. And then I get this equation. So 0.15x plus 0.23y equals, now be careful, you still need to do concentration over here, which is 0.18, but you know your total, it's 25%, or 25 milliliters, excuse me. And so they get to this point and they're like, well, now I have two variables, how do I solve? Well, it kind of goes back to what we talked about yesterday, is that X and Y, we actually know the relationship between them, even though it's not said directly up here. It's intuitive because you end up with 25 milliliters. So what happens is X plus Y must equal 25. So if you're dumping two things together to get 25 milliliters, together they equal 25 milliliters. So if I solve this for Y, Y is going to equal 25 minus X. And so now I can change my equation to this, 0.23, and now 25 minus X, 0.18, and then 25. Okay. Now I have one variable. Now I can actually go and solve what I'm doing. And again, yes, you could graph. This is almost easier algebraically, because you could, just distribute what you've got there, and you end up with X equals 15.63. If you distribute that 0.23 and then combine like terms, it's pretty much done at that point. Now, X we said was the 15, so of the 15%. And then to get Y, we just do 25 minus that number. So I would use 9.37 milliliters of your 23% solution. Okay. Again, you're going to see one of these. They do a nice job in the book of kind of helping you through and seeing that. I just warn you, the questions at the bottom of one of the columns, so if these are like the two columns of problems in your book, it starts here, but there is part of it up top that helps immensely with a picture version of kind of what you're doing. So make sure you see kind of both parts there. All right, for this last question, I want to revisit something you have already done, and maybe, it'll make a little more sense now that we've been focusing more on some word problems. So this was back in your P5 to P7 sections. So it says a soccer field has length 15 yards longer than it is wide. So I'm like, okay, soccer field is a rectangle. I'm going to have length and width, and it says it's 15 feet longer than it is wide, which means L is going to be W plus 15, because I want that to be the bigger one. And it says my total area is 3,000. So what is the length? What is the width? So very similar to what we did yesterday. You've got a number. You've got two variables in this case, but we know how they relate to each other, so we can do some substitution. What's a little new is now we're going to solve. So I know to find area, it's length times width, but instead of saying length, I'm going to put the W plus 15 so that I have the same variable. Okay. Now to solve this, you really have two options. You can do Y1, Y2. You can subtract, so I can distribute Y squared 15, I'm sorry, W minus 3,000 equals 0. And then I could graph Y1 and find the 0. Up here, I'd be finding the intersection. Either version of that, which this is all kind of back to P5 there, either one is perfectly fine. I tend to go with the first option here, finding the intersection, but whatever works for you, go for it. So if you want to practice on your calculator, you should get that your width is 47.78, and that means your length is 62.78 if you add that 15 to it for that. All right, that is it for kind of new examples. We're going to have you practice some. These are just a few more relationships that I wanted to make sure you knew or reviewed, I guess, maybe. So distance, rate, time, kind of their relationship. Rate is distance over time, or D equals RT. You might have seen that in like a physics-based science class. Here's that concentration that I talked about, that it's like your percent decimal times the amount that you have. And then these really go with kind of an econ class, which not everybody has had at this point. So if you're talking about cost, there's two types of costs. There's fixed, which are stuff that's the same every month. So we call them overhead costs. Maybe your heating's the same, which usually that might vary, but your rent is the same, your taxes are the same. But then there's also cost for actually making whatever item you're making. So your making height chairs, how much does it cost to make each one? Okay, revenue is the money that you bring in. So you're selling whatever the height chairs you're making, so how much are you selling them for times the amount you sell. Together then, those can find your profit, which profit does not have to be positive. It can be negative that you're losing money, but profit is found by your revenue minus your cost. Okay, so just a couple things that will show up there. Please check Canvas. Your assignment has been edited. There's part you're doing, and we skip a couple. It's still odds, but kind of change things around for where we are right now. So let me know if you have questions. Hope this video made sense. If you, like I said, if you need anything, just reach out as we're finishing up here.